Yes, students, hello. I hope you have understood the chapter solution. I am going to start new chapter, that is surface chemistry. Okay. This branch deals with the nature of the surface and the species present on it. Okay. So the main term that we will study in this is what? Adsorption. Adsorption means the molecules are get attached to the surface of the substance, or you can say that it is a accumulation of molecules of a substance on the surface rather than the bulk of a solid or liquid, which results in the high concentration of the molecules on the surface. So if this is a metal surface, so accumulation of the molecules that take place over it, and thus the concentration is increased rather than bulk will not go inside on the surface only, and thus the increases the surface rather than the bulk. This is known as adsorption. So many examples are there. This powdered charcoal on the metal surface, gases like oxygen, then hydrogen, carbon monoxide, they all adsorb over the charcoal. Okay, many examples are there. Now two things are there here. The substance with one is adsorbed, that is it get adsorbed, you can say. The other is on which it get adsorbed. So the one which is get adsorbed is known as adsorbate, and the on which it is adsorbed is known as adsorbent. Okay. The reverse process is known as desorption. So reverse process will be what? Removal of adsorbed substance from the surface. And the process of adsorption of gas on metal surface is known as occlusion. So these are certain terms: desorption, occlusion and adsorption that you use in the surface chemistry. Now what is the difference between the adsorption and absorption? You have heard the term absorption also. What is the difference between these two? This is surface phenomena. But this is what? Bulk phenomena. Concentration of surface is more, On surface is more. Here it is different from the bulk, but here concentration is same throughout the bulk. Then third is that the rate of adsorption is high in the beginning, but decreases till equilibrium is achieved. Yeah, here the rate of adsorption remains same throughout the process. So that is the difference between adsorption and absorption. So bulk phenomenon means the adsorption means the whole molecules will suppose this is the bulk, which will be uniformly absorbed inside, whereas this adsorption is the surface phenomenon. Concentration over this is higher as compared to here, it will be equally distributed, concentration is same throughout. And rate of adsorption, first when the molecules are more highly, they get adsorbed very quickly, and slowly when the equilibrium is reached, it decreases, whereas the rate of adsorption remains the same throughout the process. Now type of adsorption, that is two types are there. Physical adsorption means physisorption, and chemical adsorption, that is absorption means chemi-absorption, you can say chemisorption. As the name suggests, one is the physical and the other is chemical involved. Means the bond that will be formed will be here only there is attachment physically, here the chemically bonded. In this case, so it will be chemically bonded. So let us see with the means by making the difference between the two, you can understand both the terms. Okay, so here thus when the gas is held on the surface, then it is surface phenomenon, you know, and the attachment is by what? Van der Waals force. You know that is weaker. Whereas here this is held to the surface of solid by force, which is nothing but the chemical bond. It can be either ionic or covalent. Then it's not specific in nature. Any surface can adsorb, whereas this must be specific. A bond is to be formed, so it must be specific. Okay. Then always reversible. Adsorption, desorption takes place. Here, irreversible. You cannot reverse back. Then always enthalpy heat of adsorption is low, only to 20 to 40 kilojoules, whereas here it is high, it is 42, you can have 400. It is always high. Then it forms multimolecular layer, whereas this only forms unimolecular layer. So the differences, it is important. Okay. It does not require one more difference. Energy of activation. Here it requires energy of activation. So difference is over. Then what are the similarities between these two? It increases, means the adsorption increases with increase in pressure. Similar is the case in chemiabsorption also, and also it increases with increase in surface area. So these are both similar points between the physical and chemical adsorption. Okay. Now adsorption. Yes, I have seen that there is enthalpy of heat of adsorption. Adsorption is an exothermic process. That is surface energy decreases and appears in the form of heat of adsorption. Okay, so as it is adsorption is exothermic, you can say that del adsorption is negative. So when a gas is adsorbed on the adsorbate, its freedom of movement gets restricted. Okay, so what will happen? What will be the entropy change here? So after the adsorption, there is decrease in the entropy of the gas, that is del S will be equal to negative. So during the adsorption, what will happen? The entropy decreases. Okay, so you know that del G is equal to del H minus T del S, and you know for a at constant temperature for spontaneous reaction the del G must be what? Negative. So for this, what will happen? The del H must be highly negative, and as what? T del S is equal to positive. Here T del is positive. This is must be negative and this must be more negative. Okay. So in the beginning of the adsorption process, which is spontaneous, the combination of the two factors, that is del G and del H, makes del G equal to negative. But as the adsorption process proceeds, del H becomes less negative, and thus del H is equal to T del S, and del G becomes 0, and a state of equilibrium is reached called adsorption equilibrium. Okay. I hope you understood this. Next topic is catalysis. Catalysis. We have studied different catalysts to the reactions where you use the catalyst. You know what is the function of the catalyst. It does not take part in the reaction, just it changes the speed of the chemical reaction. Okay. So for example 2KClO3, it gives 2KCl and oxygen gas. Here MnO2 is used as a catalyst. Okay, so there are two types of catalyst. One is positive and the other is negative catalyst. So we can say the which increases the speed we can say as positive, and which decreases speed of the reaction you can say it as negative catalyst. Example, SO2 changes to SO3 in presence of nitric oxide. This is lead chamber process of formation of sulfur trioxide, and here this is positive. If H2O2 gives H2O plus oxygen in presence of glycerol and S3PO3, the catalyst used here, it is negative catalyst, that is decreases the speed of the reaction. So this is the first type of catalyst, that is the positive and negative catalyst. Then second is promoters and catalytic poison. As the name suggests, promoters, if the substance it enhances the activity, you will call it as a catalytic promoter. Okay, enhance the activity of the catalyst. For example, molybdenum, it acts as the promoter. So in a reaction N2 plus 3H2 to form ammonia, that is the Haber's process, you use iron as a catalyst, and molybdenum it acts as a promoter for the catalyst iron. So that is promoter. Then what is catalytic poison? So which decreases the activity of the catalyst is what? Catalytic poison. Arsenic, cobalt, if they are present, it lowers the activity of catalyst, and therefore it will be called as catalytic poison. Okay, arsenic and cobalt. Then we can classify the catalysts into heterogeneous and homogeneous catalysts. Homogeneous and heterogeneous catalysts. See, if the reactants are present in the same phase, reactants and catalysts both are in the same phase, that is reactants and catalysts. If both are in the same phase, we will say that it is homogeneous. For example, 2SO2 plus O2 gives 2SO3 in the presence of NO, which is also a gas. Then the one which reactants as well as catalysts both are in different phase. Then we will call it as heterogeneous catalyst. For example, 2SO2 in presence of platinum, it is solid, this is gas. So we will say this is as a heterogeneous. Okay. Then we have enzymes. You know about the enzymes. They are highly specific in action highly efficient, specific in nature, active under optimum temperature. It must have an optimum temperature of 298 to 310 temperature, and the pH must be around 5 to 7. Then only it will be active. Now, what is the mechanism of the enzyme catalysis? So we know that it is highly specific in nature due to due to the presence of specific regions, that is known as active site on the surface. It is specific in nature. Okay, and what are these active sites? They are nothing but the functional groups that are present on the enzymes, such as NH2, COH, OH, SH, thiol, etc., which forms weak bond like hydrogen bond or van der Waals force. Okay, with the adsorbate. So the shape of action site is like a cavity where only a specific substrate can, it is like a cavity, you know, where a specific substrate can only fit. Like one key, you know, key only fits with a particular, in a particular lock. In the same way, the shape of the active site is like a cavity. Cavity means in the lock you have cavity and you put the key inside, and a particular key will only fit in that lock. Similarly is the mechanism of the enzyme and the substrate. The specific binding, that is, there is specific binding between these two and forms enzyme substrate complex. Once proper orientation is achieved here, then the molecule react to form the products, and this model is known as lock and key model. The mechanism is which type of mechanism? Lock and key model mechanism. So the first step is that formation of enzyme substrate complex. How? So enzyme plus substrate, it forms enzyme substrate. So if you see that, suppose this is the enzyme. So the substrate will be like this. So that this go and inside and it becomes same way, you know. So when it will go, so with this is the reactant, your substrate, and this is the enzyme. So it will form the complex like this. How it is attached here, just you can show this like this, in this way. Second step is dissociation. Of this to form products. Again you will get what? It does not take part in the reaction. No, it only enhances the reaction, so it will form the products. In this way, the mechanism is given. Similarly is the case with the adsorption theory or heterogenetic catalytic reactions. Okay, so you have platinum site, suppose the catalyst platinum here. Okay, so suppose A, B is the molecule that comes and attached here. So both come here and they get attached here. So we will say that a complex is formed, and after the chemical absorption, what will happen? The bond between this will break and it will get attached here. But this theory does not explain the action of catalytic promoters and catalytic poison. It get attached and then slowly it will, then again after the reaction you will get platinum and plus AB. Not so much important. Then in the catalysis only one small important topic is there, that is known as shape selective catalysis, that is by zeolite. So the catalytic reactions which depend upon the pore structure of catalyst and size of the reactant and product molecules they are known as shape selective catalysts. So the catalytic reaction which depends upon the pore structure of the catalyst and the size and the reactant and products of the molecules is known as shape selective catalyst. Okay, they have a honeycomb-like structure. Honeycomb-like structure, and example is aluminosilicates. Aluminosilicates having ALOSI network. Formula is MX by N Al2O3 X times, then SiO2 Y times MH2O. Now Mn plus, this is what? Metal cation, and it can be Na plus, Ca2 plus, K plus, etc. And N is the number of molecules of H2O. They are used in petrochemical industries for cracking of hydrocarbons and isomerization. Example, GSM5. Okay, this is the catalyst that is used in the petrochemical industry. This hydrated zeolite is also used as ion exchangers in softening of hard water. So it was just an introduction and a few topics I have dealt with, that is catalyst and enzymes. Okay. Now some characteristic features are there that you can go through the book and see what are the characteristics of the this catalyst, important features of solid catalyst, then enzyme catalyst. Okay, you go through the book. I am not going to take such small portions. You go through the book. Now the next important topic is catalytic adsorption isotherm. Okay, that is known as adsorption isotherm. Adsorption isotherm. Isotherm means, if you draw a graph where the temperature is constant, you are saying, then it will be what? Isotherm. Hai na? So if you plot a graph between the fixed pressure and increase in temperature, there is decrease in physical adsorption with increase in temperature. And okay, if the temperature remains constant, we will call the graph as isotherm. So adsorption on the surface remains constant at equilibrium. It increases with increase in pressure of the gas. It increases with increase in concentration, and the extent of adsorption is given by x by m, where x is the mass of the adsorbate and m is the mass of the adsorbent, and x by m is known as what? Extent of adsorption. It depends upon the pressure of the gas. The relationship between the amount of gas adsorbed by the adsorbent and pressure at constant temperature, we call it as adsorption isotherm. So if you plot graph between x by m and pressure, the curves that you get is nothing but the adsorption isotherm, where the temperature remains constant here. Okay. So if you see this graph, what you see that after certain time the temperature remains constant, and you have the pressure corresponding to this is as, we call it as PS, saturation pressure. So it becomes maximum corresponding to the pressure called the this is what PS is, nothing but saturation pressure or equilibrium pressure. Okay. The extent of adsorption becomes constant through pressure increase, and we call that saturation pressure. This type of adsorption is observed when the adsorbate forms a uniform molecular layer on the surface of the adsorption. Adsorbent. Unimolecular layer, where it is formed over the surface of the adsorbent. And which adsorption isotherm. In 1909, he gave an empirical mathematical relationship between the extent of adsorption with pressure at a particular temperature, called Friendly's adsorption isotherm. Okay, so the graph that is there, we have now just so that x by m and pressure, you get the graph. That graph was, according to that graph, he gave an mathematical expression. So from the graph, the following observations are made. At low pressure, graph is almost straight. So let me go the graph, almost straight, then some curve, and then it becomes constant. Okay, x by m and pressure. So at low pressure, what you see, the graph is almost straight line, which indicates that x by m is directly proportional to pressure, or x by m equal to k P dash, and K is the constant. Then second, at high pressure, the graph become almost constant, that is x by m is independent of pressure, or you can say x by m is equal to constant, or x by m is equal to, suppose you take P naught, so x by m equal to K P naught you will get. Here P naught is equal to 1. Now in the intermediate range of pressure, that is x by m depend upon either 0 or 1. 0, here P naught is nothing but 0, and this is 1. So intermediate, third is intermediate range of pressure. X by m, it depends upon either two values, that is 0 and or 1. So we can write this as x by m is proportional to p 1 upon n, where 1 upon n can have values 0 and 1. So x by m, so this is the third one, no? X by m will be equal to kp raised to the power 1 upon n. So n is the whole number. It depends upon the nature of the adsorbent and the adsorbate. This relation is known as Freundlich adsorption isotherm. So here this is x by m, here is x by m is equal to k p1. This is constant, so x by m equal to k p0, and in between this nothing but x by m equal to k p1 raised to 1 upon n. Now how to calculate the values of k and n? Calculation of k and n of the adsorption isotherm. So log n, take log on both sides, log x by m is equal to log k प्लस log लेंगे तो 1 upon n यहाँ आ जाएगा log p. So y is equal to c plus mx. So slope of line is 1 upon n. So if you draw the graph between log x by m and log p, no, this is x by m is y, then x is x by m, sorry, x में log p आएगा ना, okay, log p. So you'll get a straight line like this, where the intercept will give log k and the slope will give 1 upon n. Okay. This shows that the validity of the Freundlich isotherm, because we get a straight line. The slope of the straight line gives the value of 1 by n. But some limitations are there. What are the limitations? We will see. Limitations of the Freundlich adsorption isotherm. This equation is valid only for a certain range of temperature, range of pressure. It explains the adsorption behavior in an appropriate manner only. The factor 1 by n can have 0 and 1 values, that is the probable values. Range 0.1 to 0.5. Thus the equation holds only for a limited range of pressure. When 1 by n is equal to 0, x by m equal to constant, adsorption is independent of pressure. When 1 by n is equal to 0, x by m will be equal to k, that is x by m is directly proportional to pressure. That is adsorption varies directly with pressure, that is applicable only at low pressure. So both the conditions are supported by experimental results, thus it fails at higher pressure. So this isotherm, it fails at high pressure of gas, then it is valid only for a certain range of pressure I have told you. Okay. So that's all for today. Hope you have understood the portion whatever I taught now in this video. Okay.